In this video, we're going to discuss graphing linear equations, or graphing lines. Let's look at an example. Y is equal to 2x plus 3. Whenever we have an equation and y is equal to mx plus b form, m is the slope, so in this case 2 would be the slope, and b, which in this case is 3, would be the y-intercept. Whenever we graph a line, a linear equation, we start with the y-intercept. So we're going to graph our first point at 0, 3. Then we use the slope. The slope in this case is 2, or 2 over 1. If you remember, the slope is really delta y over delta x, which is the change in y values over the change in x values. So for every 2 units that we move up, we move 1 unit to the right. Let's do that. We're moving up 2 units and 1 unit to the right, that's another point. Up 2 units, 1 unit to the right, that's another point. Up 2 units, 1 unit to the right, that's another point. Now we can connect these points to make a line. But let's say we didn't want our line to stop by the y-axis. Let's say we wanted our line to continue down into quadrant 2 and quadrant 3. If you remember that 2 over 1 is the same thing as negative 2 over negative 1. We could rewrite our slope as negative 2 over negative 1 because negative 2 over negative 1 is the same thing as positive 2 over positive 1, and we could use that to continue graphing the line. That means we would have a change in y. We would go down 2, and negative 1 means we're moving to the left instead of to the right. So if we go down 2, we move 1 to the left. That's another point. Down 2, 1 to the left. That's another point. Down 2, 1 to the left. That's another point. And now we can continue connecting our points. And you could go on down the graph, down the whole page. But you could just remember that all linear functions go on forever in both the x direction, the horizontal direction, and the y direction, the vertical up and down direction. So always make sure to put arrows at the end of your line to show that it doesn't stop there, it goes on forever and ever. Let's look at another example. Let's say we have the line y is equal to negative 1 over 3x plus 1. We always want to start with the y-intercept, which in this case would be 0, 1. So let's put a point over there. And then we move on to use our slope. And the slope in this case is negative 1 over 3, which means that our change in y is down 1 for every change in x of going to the right 3 units. So let's go down 1, 1, 2, 3 units to the right. Down 1, 1, 2, 3 units to the right. Down 1, 3 units to the right. And this would be part of our line. And we could connect our points. This is our line. You always want to put arrows at the end of your line to show that the line doesn't stop there. It goes on forever and ever in both the horizontal direction and the vertical direction. Let's say you wanted to continue your line into quadrant 2. Remember that negative 1 over 3 is the same thing as 1 over negative 3. That means that your change in y is now up 1 for every change in x. A negative change in x means it's moving to the left, so it's moving to the left 3. So let's continue graphing that. We're going up 1 and left 3. That's another point. Up 1 and left 3. That's another point. And we could keep on going on forever. We, of course, do want to put arrows at the end of the line to show that it goes on forever. And this would be your line.